This is AS Stats. We are on Unit 5 and we're taking a look at the binomial distribution, and it's just a wee bit of revision then of some of the pure maths that you will have done then just for the binomial expansion. So here's really where it comes from. Say you have A plus B upon A plus B. You've been multiplying that sort of thing out for about 3 or 4 years. So you would get then A squared plus 2AB plus B squared. If you then had 3 brackets, A plus B, A plus B, A plus B, you could sit and multiply it out. Straightforward enough. 4 brackets, 5 brackets, 6 brackets. Once it gets to about there, it gets fairly cumbersome to multiply it out, and so we tend to use a binomial expansion instead then to multiply it out. So how does that work? Let's pick one at random. I'd pick A plus B to the power 4 and see where we go from that. And I would, whenever I'm doing pure maths, I tend to start here with A to the power 4, A to the power 3, but I'm going to go the other way around. It's more useful whenever we're doing probability and the binomial distribution if we do it the other way. So what happens is we have an NCR number, so I would have 4C0, A to the power 0, B to the power 4. We'll talk about where this number comes from in a wee second. Plus 4C1, A to the power 1, B to the power 3, plus 4C2, A to the power 2, B to the power 2, plus 4C3, A to the power 3, B, plus 4C4, A to the power 4, B to the power 0. Just about fitted that in. These numbers, I hope you remember, you can either get from the Pascal's triangle where you sit and expand it out, or you can use the NCR button on your calculator. So on this particular calculator, it's just here. There, do you see it? It's just above the divide sign. So say I wanted to see 4, let's go for 4C2, we'll try. So I would type in then 4 shift divide 2. So you can see what's come up there in the calculator, 4C2, it equals, and it gives me 6, so that generates that number there. So if I'm expanding this out and tidying it up then, I would end up with 4C0, that ends up being 1, so I have A to the 0, B to the 4. 4C1, put it in your calculator or use Pascal's triangle, it's going to be 4AB cubed. This is the one I put in the calculator, 6 A squared B squared plus 4A cubed B plus 1 A to the 4 B to the 0. You can obviously tidy this up again very slightly by dropping the A to the 0 and the B to the 0, and that's where we are. But I hope you see the pattern there on how it all works out. So powers of A increase 0, 1, 2, 3, 4. Powers of B decrease 4, 3, 2, 1, 0. And then the number that comes in front then will be your NCR number, either coming from Pascal's triangle or you can use that NCR button in your calculator. There's another way of working it out, you maybe remembered as well, involving factorials, but that's kind of where we are. So it's a wee reminder about how these things work out. Let's do another one, and I'm going to change my letters here from A and B to P and Q. And let's go for P plus Q to the power of 6. Let's see if I can write small enough to actually fit this in, and see if you can follow this in as I go. So is this going to be 6C0, P to the power 0, Q to the power 6. As I go along, what happens to this? 6C1. Power of P starts to rise, P to the 1, Q to the 5, plus 6C2, P to the power 2, Q to the power 4. Notice the 0 and the 6, the 1 and the 5, the 2 and the 4, they always add to whatever this number is here. Hopefully that helps as well. Plus 6C3, P to the 3, Q to the 3, plus 6C4, P to the 4, Q squared, plus 6C5, P to the 5, Q, plus 6c, 6 p to the 6 q to the 0. Again, let's get our numbers. This one's always going to be a 1, so we have just q to the 6 because the p to the 0 disappears, plus 6, so 6c1 would give us 6, so 6p q to the 5. Let's work out 6c2 for us here actually, so 6c2 is 15 p squared q to the 4. 6c3 I think it's 20, let's check. 6 is 20 p cubed q cubed. 6c4 is just going to be the same as 6c2, so it's going to be 15 p to the 4 q squared plus 6 p to the 5 q plus p to the power of 6. So that's the sort of thing you would have expected to have done then during your AS Pure Maths, and you should be comfortable with multiplying those out. You could sit and multiply out this bracket 6 times, you will end up with this. It's just going to be the same thing, but obviously once you get up within our binomial distribution here, we need to go much higher than 6, like it go up to kind of 50 or different bits and pieces there. So obviously you're not going to be sitting doing that and multiplying out those brackets, but that's just a wee bit of revision about our binomial expansion.